Hello everyone. This video we are discussing the code of cross validation. We have created this cross validation code for Matlab users because I think cross validation is not available with the Matlab libraries. Although it is very standard code and it is used to tune the hyperparameters on the grid search over the parameter values to identify the optimal values of the hyperparameters based on a particular performance parameter. So I hope with the start of this video, I hope that you know what is a cross validation, what is a k-fold cross validation to tune hyperparameters, especially with grid search. So that's the baseline that we expect the users to know. Now we are going to discuss these two files especially. One is cross validation, another one is blocking. So these two files you require to make your code and to cross validate your code over a list of parameters, and this list of parameters will be discussed with a grid search. So for every combination of values of all the parameters in the parameter list, the values will be discussed, and once the values will be discussed, those values on those values the hyperparameter values will be calculated. And accordingly the optimal hyperparameters are reported. Okay, so let's go through the major idea about this first thing, the cross validation. So there are 1, 2, 3, 4, 5, 6 and 7 parameters. We have foldable data, the data that you want to create folds. So since we are talking about k-fold cross validation, so the k folds to be created on the stratified samples. So we, in this particular implementation, we hope that you would prefer stratified sampling. In that sense, like we have the foldable data is a structure of or array of structures containing a data member, and the data member is an array. It's a two-dimensional array containing some samples and attributes along with the target attribute, which is in the last column. So that is the idea that we understand, right? So that's the foldable data. So this foldable data you are hoping to train on. So let's say you do the k parts of it, k parts of each class, and from those k parts, k-1 will be taken as the training data, and the one part will be taken as the test data. The other para is a structure containing all those parameters whose values are fixed. So for example, the structure of all the, so you know, sometimes you feel that you want to have the kernel to be a particular value of a particular kernel you want. For example, maybe linear kernel or maybe RBF kernel only you want to know. So that other para will keep all those information. The parameter list is the list of all those parameters values on which you want to perform the grid search. So the values of those parameters will be the first parameter and the corresponding values. All those values will be listed in this way. So second parameter and its expected values, all those values will be listed like this, and we will be conducting the cross validation on the all possible combination of these values. So the first parameter value 1 and the second parameter value 4, first parameter value 1 and the second parameter value 7, 8 or 3. Similarly, first parameter value to be 2 and then second parameter value will be 4, 7, 8 or 3, and so on and so forth. So similarly, you can have more number of parameters. It does not actually bound you on the number of parameters as such. Then we have these three function handles. So the train func is the handle to the training function, test func is the handle to the prediction function, and it returns the structure containing a PC, that is predicted class field or predicted label, target label you need to predict, and that should contain a PC field which keeps the predicted target value, and there is an act field in the output parameter of test func. This act field will be actually containing the actual target values. Okay. Looking at the train function, it is a handle to the training functions and it returns an out structure. So, and this out structure will be directly fed to test function. So, whatever model parameters that you think after training you require for prediction purpose, you can put it into the structure, and that you give it as a output value of this function, train function, right? And then we have a performance para. Performance para is a handle to the performance parameter evaluation function. So you will be given the actual target value and the predicted target values. Both the things are given, and according to those two values you will be creating, or you will be identifying what are the performance parameter values, and the lower value will be considered to tune the hyperparameter. For the optimal parameter, optimal value of hyperparameters, lower values of the performance parameter is considered. So performance parameter is actually giving you an structure. It's an output which is a structure type with an attribute ERR. Now this ERR will contain the error, or presumably the something which if you minimize you will get the better value of hyperparameters, optimal value of hyperparameters, right? And the opt para. Opt para is the output of this function. So you can see here is this opt para. Opt para is the output of the cross validation function. This opt para has two special parameters. So two data members structure. The parameter is containing the all combination of parameters. So all possible values of the parameters you will get, on which the model has been tuned for or cross-validated for, and the opt para contains the error. So it contains for a particular parameter combination, it gives you error, right? So let's say if you have 100 combinations of parameters, then you have 100 errors corresponding to each parameter combination over entire cross-validation, k-fold cross-validation, right? Okay. Now look at this. We first have a AND loop. AND loop gives me the total number of parameter combinations. So we have created a parameter named array, which actually houses all the combination of parameters. In each row you have a particular combination which can be utilized for a particular value of hyperparameters, and then the cross validation performance parameters will be evaluated. Okay. Then for each parameter combination we have gone through all possible folds. For every time if you are going through fold, you generated the jth fold is, or jth part of the entire data will be considered for the test fold, and the rest of the part will be considered for the train fold. The train fold and test fold have the same structure as of the foldable data, which means that foldable data, since as the foldable data has a data member data as a data member, which houses the sample information along with the target value. So for every particular class you have a structure, and in that particular thing you have a data, and in that data we have the entire samples information along with their class label in the last column. Then we have, let's say, how many folds you are considering. So k fold cross validation. For that k, you are passing that k, and which particular fold it is at this particular point in time it's running, that is j, right? Then you call for the train function, wherein you pass the training data, you pass the parameters that are fixed parameters, and you pass the parameters which are to be considered for the parameter tuning. So for a particular combination of the parameters that we consider here. Finally, this train function gives you an MDL as an output, which is the model parameters after training. This MDL is actually passed into the test function for the prediction purpose, right? And the train fold and test fold both are passed. Then parameter fixed value, so the parameter combination is passed, and the fixed parameters are also passed over here, right? So once you have done this, that one structure comes out from this particular function. This structure is actually containing two different values, ACT and PC. ACT is the actual value of the target variable or target values, and this is predicted values. And accordingly, the performance parameter calculates another structure called val. The val should have an ERR component or data member. This ERR should be minimized to find out the better values, right? So this ERR is accumulated in the error, right? So that is what we have considered. Okay, so that's all. And let's look at the blocking one. The blocking function, what it does, the blocking function actually takes the foldable data, the entire foldable data that you want to fold upon, then which k fold cross validation you want to do, that is here, and I is a particular fold that is currently running is in the consideration. So that is it. So test fold and train fold, both of them are array of structures, and both of them have a dot data member. So like foldable data is also having dot data member. Similarly, train fold dot data is also there, and test fold dot data is also there. So it's an array, so you will be having an index over foldable data. Similarly, test fold and train fold will also have the indexing. So this index is based on the class. So for every class we have actually considered a particular index, and for that index you have dot data, and in that dot data you have the entire information about the samples of that class along with the target attribute. So that is the class label. Okay, and we are putting the jth portion of the entire data. So the jth portion we will keep in the test fold, and the entire rest of the entire data is taken in the train fold of j. So j is the class, a particular class, right? Okay. So that's all, but let's try to visualize it with a particular example. So we have a main function. Here is the main function. Main function is the function wherein you actually loads the data, loads the actual data, and tries to do all those things. Let's see what we can do. So let's try to understand this main code, how it happens. So we are taking this spiral file. This spiral.mat is actually containing a data set, entire data set, and the entire data set we are having. So we are putting the foldable data. So how this foldable data looks like. So let me just show you how this foldable data is keeping the information. The foldable data has a particular member, data member dot data, and it contains all the information of a particular class. So all the samples of a particular class along with the class label in the as a last column of that class. So it keeps all that information, right? So you can go through this information. You may also want to keep all other variables. If you don't want, you can actually switch them off. So however, in case of cross validation, we have not considered this information, so we can keep it as a separate one. Okay. So ultimately, what you need to create a foldable data kind of a variable, which is an array of structures, and a data member is there, and that data member is containing all the samples of a particular ith class, right? So that is there. Okay. So this foldable data is created, and these are our parameter list. So the parameter list is also an array of structures, and at each index you have values, data member, and this data member keeps the entire range of values on which you want the cross validation to run. So for every value of C1VS, every value of C2VS, C3VS, delta VS, KNL VS, we are going to grid search over them at what particular combination of that parameter. So a particular value of C1VS, C2VS, C3VS, delta VS, and KNL VS, at what particular values of these particular variables our model gives the best performance. So the least ERR basically. The other parameter contains all those parameters which are fixed. And then train func is a handle to a function which is going to train your model. Then predict, the test function is a handle to a function which is actually going to predict your model. And the performance parameter is handle to the function which actually generates the performance parameters for the model. Okay, and the fold is actually the k-fold cross validation, so that the value of k is in the fold. And finally, you save the entire output of this cross validation in opt_para. So this opt_para is going to save in a particular file, which is spiral_res.mat. So if you want, you can actually load it again, and then you can look at it. If you want to make some kind of graphs or some kind of things, then it is reasonably, you can give, or it can give you an idea on the cross validation things. You can actually create graphs. Okay. So let's look at the fitness function or the fit function, so which is going to actually going to create your model. So how does it look like? So what is happening here? Here we have a foldable train data, and we have other parameters, and a particular combination of parameters we have. This other para is fixed values or parameters that are fixed. So we have that, and the foldable train data again keeps all the information about all the different classes at a different index. The dot data actually keeps the information of all the parameter, all the class features. So here you can see we have taken. So this is a particular model, so we need not to actually understand, but just to make you understand the what is the connection of these three parameters with your own model. So this is the training data. So correspondingly, for a particular index, you will getting a particular class data over here. So in the same sequence which you are passing in the first go, right? So whatever order you have already creating with the foldable data over here. So you may be yourself creating the foldable data over here. If you do that, it works very fine, right? In the same sequence you can actually take. So accordingly you can think about it. And even if you want to actually find out which particular class label it is, you can actually look at the last attribute of dot data member, and that last attribute is exactly same as what you have actually already given. And then there are fixed parameters you can actually put it, and then the parameter values. So for example, we have, so parameter 1 is assigned to C1, parameter 2 is assigned to C2, and so on and so forth. So in this way you have to actually take it. So this particular line you have to understand, in the sense that whenever you are actually taking this parameter, a particular combination of parameter is coming. So correspondingly you have to assign it to your variables on which you are actually going to cross validate, right? So how you assign it, it does not matter, right? So it's just an example. So I took it this way, and that's it. Okay, finally if you look at it, we have made a MDL variable with which we have considered some of the things in a structure to put together, so that the predict function can take care of it. Look at the predict function. So again, that foldable data, train data is actually going to give you all the training data. Then these are the fixed parameters, and then this is model parameter, whatever model from the trained model you want the variables, you can take those variables, those values, and correspondingly you can actually have generate a result structure which has predicted class labels and actual class labels, or actual target values and predicted target values, and you return it. You return it, right? Once you've done that, okay, this all is done. So then the performance parameter are calculated. So the performance parameter, this is going to give you a val structure. This structure should have ERR data member, and that should keep the value. And we have accumulated this in the ERROR variable, which we have appended it into the structure optpara, which is the output of this cross validation. So that's all about this cross validation and how you can utilize it. You need two files, cross validation and blocking. Look at this, this entire documentation for the purpose if you want to use it. And if you have any doubt, you can email me at this place. So that my name is Kapil, author is Kapil, and my email is here. So you can email me here, right? Thank you.